In this video, we're going to look at an example of sketching a contour map of a function of two variables. So we're given the function f of xy equals natural log of the quantity x squared plus y squared. Remember, to create a contour map, we're going to set the function equal to numbers, whatever those numbers happen to be. And those numbers represent slices of the surface that where we take the plane z equals that number and slice right through the surface. Okay? So if we set the function equal to c, then we get this equation, c equals natural log of x squared plus 4y squared. Or if we raise both sides e to that power, we get x squared plus y squared equals e to the c. Now e to the c is just a constant. If z is equal to some constant, e to the c is still a constant. So what we really have here are equations of ellipses. They'll be centered at the origin. And the major axis, since if I divide by e to the c, I'm going to get a bigger number on bottom for the x squared than I get for the y squared. So my major axis will be along the x-axis rather than the y. And certainly as c increases, e to the c increases really, really rapidly. So the level curves here will spread out really, really quickly. So below, I've just picked the numbers -2, 0, 2, and 4 for c. And you can see that here's c equal to -2, here's c equal to 0. They're relatively closer together. But by the time I put in 2, it's a little farther away. And by the time I put in 4, it's really farther away. So again, the larger c gets, the farther away these contours are going to get, and they're going to go really rapidly and get wider.